maybe before, as Chris gave an intro, but we really noticed there's a lot of confusion over and over again on NAT traversal and dealing with turn servers and ICE. So I'm going to do some more basics on that. Maybe before I dive into that, I'd be curious, what percentage of the audience would you consider yourselves IP network engineers, experts? Anyone out there? No IP networking? We got a couple. Web developers? A lot of web developers. How about mobile developers? Good. All right. So this hopefully will be informative and teach you just enough to be dangerous, but also get you through some of the thornier issues with dealing with getting through firewalls and NATs. And really, as Chris mentioned, one of the biggest problems is when you're dealing with end users and something goes wrong, you can't tell them that they need to go and reconfigure their network, right? It's not just like hanging up and dialing again. All right, some of these problems are much more complex than that. Fortunately, WebRTC includes capabilities to deal with this. But let's first walk through the NAT traversal problem in the first place. And it really comes down to, starting out, we're used to a normal client-server type architecture when serving web pages. That's fairly simple, right? We're dealing with public servers in most cases, and there's no challenges there. WebRTC is a lot more challenging because in this case, we're dealing with peer-to-peer media, right? It takes a different path, a direct path between, a client on one side and a client on the other side, right? The real problem comes into play when you have these devices called NATs, network address translation, right? And these are essential, especially in IP4 networks, enterprise environments, where you want to segment off your LAN environment and have that be separate from your WAN, your wide area network environment. And in a typical setup here, your LAN has a different IP address space than you do on the public network. And the challenge comes in when you're trying to talk from one peer to another peer. You need to address those peers, right? And which address do you do? All right? This LAN, this client here, only knows the internal address. It doesn't know the external address. Right? So one of the key tricks with WebRTC is trying to figure out how do you get that external address so you can connect one client to another. But it's not just IP addresses that are a challenge, right? There's other challenges that come into play too in NAT and firewalls. And some firewalls, a lot of firewalls actually block whole ranges of ports that go along with this, right? So there's port range blocking, right? There's also configurations and environments that might block UDP, right, instead of TCP, so different protocols. So if you're not familiar with IP networking, and there's three things you should remember when dealing with addressing in general, right? There's the core IP address, right, and there's a whole big range of these, right? There's the port, and the most typical ports that if you're a web developer you deal with is port 80 for a typical web page, or 443 if you're doing HTTPS. Right, but there's a whole range of other ports that are common for different services, IP services out there, and for WebRTC. And you need to know the protocol, right? UDP versus TCP, right? Where typically the TCP is used for in the web, and UDP is good for real-time communications. And we'll talk a little bit about why in a moment. So to solve this challenge, WebRTC includes a standard known as Interactive Connectivity Establishment, or ICE, right? And again, the whole idea behind ICE is really to allow that direct peer-to-peer communication through these NAT and firewall environments, right? And there's two main types of servers that are involved with traversing NATs. The first is called a stun server, and I'll walk through what this does, but if you really want to know the acronym, it's a session traversal for utilities for NAT. And then the second one is a turn server, right? Traversal using relay NAT. So how does stun work, right? Stun basically sends out a packet to the stun server and just asks, what is my IP address, right? And the stun server returns back and returns that external IP address that it sees, right? This is a really simple, lightweight mechanism. Turn server is a little bit different, right? Turn server typically sits in a public network, right? Goes through and actually anchors and relays your media for you, right? It actually sends the media through. So just a quick recap, and these are the two main servers that you need to deal with turn. The first is a stun, right? And the second is a turn server. In terms of implementation and requirements, usually you always the stun server is used almost always, right? That's definitely the most typical. Turn server, I'll show some metrics. That's also important to have in every production grade deployment that you have, and we'll show there. But some of the challenges here are the costs of these, right? The stun server is actually very inexpensive to operate. In fact, you can use Google's stun server for free. It doesn't do a whole lot other than just return an IP address. The more complex one, the more expensive one is the turn server, right? And the turn server, it sucks up a lot of bandwidth, right? Because it's actually relaying all that media, and bandwidth costs money. So it's much more expensive to operate. Another challenge with turn versus stun is turn actually, because you're relaying the media through a central point, it's not really peer-to-peer anymore, right? And you have another intermediary point there that can add some delay and latency to communication. So if it's not configured correctly, or if you're have your turn server on some network that has a lot of latency, it can cause some quality issues. So how often is turn needed, right? Since we talked about stun is really no big deal, and Badri was nice enough to give some stats from TalkBox. I'll talk about some stats from others, but at least in TalkBox's environment, he's seeing anywhere from 6 to 14% in a given day. I think average there is 10 to 12%. You'll see other environments that might go up to 20% or more. It really depends on who your customers are and where you're targeting and the types of networks. Typically, enterprise environments are much more likely to utilize more restrictive NAT and firewall type policies, and you're more likely to use turn there. Other environments like an airport, even in venues like this, you might find that they turn off some firewalls and ports to prevent people from using typical VoIP services. So a little bit less of the talking. Let's talk through a little bit about actually how do you get how do you actually do some of this. And I'm going to do a live demo here real quick just to show how this works. Right? In this case, I'm using a demo based on CoTurn, which is an open source turn server. And it's actually pretty simple. In most cases, the turn servers, they just have a simple REST API. Right? You can see here, I'm just grabbing an object. Let me format this for you a little bit so we can see what's going on here. Right? And this returns what's known as an IceServers object. Right? And I'll walk through what some of these things are in this slide here. All right, so a couple pieces to this. Right? The first thing that you get when you request the IceServers object from from your turn server service or turn server, it gives you the stun. All right, your stun server. Right. The second set here, and I should note that this is using the newer format of IceServers. The old format looks slightly different. You'll find we're working with WebRTC. Things are still changing. This is one of the things that changed relatively recently is the format of the IceServers object. The old one still works, but I'm showing the new one here. And you can see here, this shows a set of different URLs for different services, and I'll talk through some of these in a little bit more detail. But the first one is UDP on a standard stun port. The second is TCP on a standard web port. You see I have port 80. And the last one is turnover TCP, right? Or turns, it's called. Turn TLS that works over the HTTPS port. Right? You see the next set, because, as I mentioned, turn servers, they relay media, they're not free, right? Typically, you don't want to give this out for free. We don't care about having credentials so much for the stun server. You can. There's nothing stopping you from doing that, but typically that's a little extraneous to do. For the turn server, you absolutely want to have some login details and credentials, right? So you see some of those details there, right? And the last item here on the bottom is the time to live, right? How long, the timeout period for these credentials, so can tell your application when to renew and get new information. Right? So to review a couple things that we saw here, so there's a couple different types of ICE candidate protocols. I mentioned UDP earlier, right? UDP is unreliable, but it's actually really good for VoIP because it doesn't end up retransmitting things that don't matter, that don't make it into the conversation anyway. VoIP is all about being in real time. You know, TCP is reliable, but it's not as great for VoIP because if a packet arrives too late, you're not going to end up playing it or using that anyway. So it's just extra processing and overhead to deal with that. And the last one I just mentioned is TLS over TCP. Right? And this is usually used for the very restrictive or weird firewalls that really block everything. You're more likely to get this through using going over the HTTPS channel. The downside of this is as you're actually doing double encryption because WebRTC includes DTLS encryption already on the media. You're actually just encrypting this again to send it over a tunnel, right? And that can cause, there's no additional security benefit in encrypting twice, right? It takes some additional time to set up that channel in the first place. And by encrypting it twice, and running over TCP especially, there is some risk of quality going down. So, and how often are these different types of relays used? And this is some stats recently from callstats.io, another a WebRTC monitoring service. You can see there, they require their customers, at least in their customer base, use Turn about 22% of the time. You can see, overall, Turn UDP is definitely the most commonly used. Turn TCP is a lot less, and really you want to avoid and minimize the use of Turn TLS, but it still comes out there. If you're running a production-grade service, you absolutely need to support or should support all of these, right? Because you're going to have, what could end up being still a meaningful number of users, and that's in that 2% that you still want to support, right? So, next thing I want to discuss a little bit is some of the different ICE candidate types, right? Just so you understand and go over the terminology. So, host candidates, right, are addresses that are just local addresses, right? This is the simplest scenario. If you're on a local LAN or if you're using an IPv6 and everything's public, you can get away with a host address, right? The server reflexive address is the address you get back from the stun server, and the relay address is the address that you get back for the turn server. Right? And let's take a look at how this works in action here. Right? And I'm going to just show a quick example using the Trickle ICE demo that's available on the official GitHub WebRTC samples as part of that. Now, I've already gone through here and pre-populated this with the credentials I had here to make sure your turn server is working correctly, right? Test different values and actually test the whole ICE process, right? So I added the different servers from the IceServers object I got back, and now I'm just going to go gather candidates, right? And you can see, just as the font's a little small here, but you can see the different types of candidates that we have that are involved in this ICE process that goes out there and just checks all the different ways it can connect to another peer, right? So we see the host here, we see the server reflexive, we see relay addresses, right? And then we see a variety of different options across TCP and UDP, right? And this is showing all the different ways it was able to find or able to connect to another peer, right? If you do set up a turn server, it's usually and you want to test it outside of your own app, the peer connection sample is really great for doing that. The official test, Sam will talk about this later, the test.webrtc.org gives you an option there if you're testing to actually plug in a separate, your own turn server to do some testing there too. There's also some ways to do it even with the official app RTC demo that we talked about a little bit earlier. So just to wrap up, I want to spend a couple minutes about just talking about, all right, you get your turn server set up. What are some of the things that you should look for or consider when moving that turn server into production? Right? And the first, and really the most important in a lot of cases, is you want to have a global distributed turn server network. We talked about the fact that if you're going to have to relay the media, right, it's going through another point in the network, and that adds some latency. So if I'm trying to connect, I'm based in Boston. If I'm trying to connect in Boston and my turn server's in Hong Kong, right, there's gonna be a lot of latency there. It's not gonna give very good voice quality. I'm much better off having a turn server that's based in New York or San Francisco or somewhere closer. So having you want to have a geographic, multiple points inside the network to help reduce the latency. You can also leverage that too to provide some geographic redundancy involved there too. So should one turn server go down, you can at least fail over and start using another turn server. Overall, turn server is actually relatively basic. It is the ICE technology, what goes on behind the scenes is really, really complex. If you're a web developer, you really don't need to know much more than what I showed here. But if you're looking to do more advanced functionality, there's a whole lot of things that you can do. Right? Today, it's a little bit difficult to do some of these things with the standard JavaScript stack, but if you're implementing your own ICE stack or you're doing a mobile implementation and you're willing to go beyond and adjust some of the APIs a bit, you can do a technique that's known as relay first, right? And you'll find this is very common in services like FaceTime or like WhatsApp. In previous Cranky Geek event, Philip Hankey, Fippo, talked about some of these techniques, right? But the idea here is you know that your turn server, you already know the address of it because it's public, it's predefined, and you can actually help to decrease the call setup time by just connecting to the turn server first, and then allowing this ICE process that goes and gathers all the candidates that I showed before to figure out the best way to see if you can do a peer-to-peer connection, right? So this is called relay first, right? You can do this to help to reduce the setup time, right, and improve reliability. But as I said, it's not built into the JavaScript yet. With some of the standards updates that are happening with the WebRTC objects, you'll be able to do this at some point. In fact, even before then, it looks like there'll be some hacks and workarounds to make this work for a web app too. So, and just to close out, so how do you get or use where do you start if you want to start using a turn server? Well, if you're using a platform as a service provider, like TalkBox, for example, most of them already include a turn server as default as part of your service. You really don't have to worry about it at all, right? If you're running your own network, want to set up your own thing, there's a number of open source projects. CoTurn is by far probably the most popular, but there's other ones out there, Restun, Num, and there's a few commercial solutions options out there also. In addition, if you're just running a service and you just need access to a turn server and you don't want to set up your own turn server network, there's a few, there's several turn as a service type offerings out there that basically, in most cases, only just charge you by the gigabit. They charge you based on the bandwidth that you use. So, just to conclude, if you're building, working on, looking for a turn server, what are some of the things that you should look for or consider as part of this, right? UDP support is basically universal. TCP support is generally there. But you might also want to ask about, can you traverse over standard web ports like port 80, port 43? What sorts of redundancy mechanisms do you have? What kind of load balancing can you offer? Have you done anything within the network to provide any latency optimizations, right? Is there logging, or how do I know what percentage of my users are using turn? That might be useful information to have because, again, there's a cost associated with turn, both an operating cost and potentially a quality cost there. So if you had good logs, you might notice, hey, this one customer, maybe their network's not configured. Maybe you can talk to them and they can change some things to improve performance, right? And then this is really probably not on the radar yet, but coming soon is, do they offer something like turn first, right? The relay first option I talked about. So this is a really, again, it can get a very, really complex problem. Fortunately, WebRTC actually simplified a lot of this down to a relative minimum what you need to deal with. Right? So if you're interested, we'll have a post on this at WebRTCHacks hopefully pretty soon to go into a little bit more detail on what I discussed here and review it, or just feel free to ask me. With that, I think maybe we have a minute or so for questions while we're setting up the next speaker. Sure, right in front. Post on this at WebRTCHacks hopefully pretty soon to go into a little bit more detail on what I discussed here and review it, or just feel free to ask me. With that, I think maybe we have a minute or so for questions while we're setting up the next speaker. Sure, right in front. Yeah.
Get your microphone first. So go ahead. Well, first of all, it was a very good presentation. What I was concerned about was that you mentioned that for natting, as well as for quality of service, um, the ICE has two methods, right? That is turn and stun. But I was just wondering, how is this different from the existing networks that we already have? Because we have these functions already built in. And I'm sure you would agree with me that quality of service is anything can pretty much affect quality of service. If you go over the WAN, there may be a drop of packets that may affect quality of service. If you're running your NIC card on a certain virtual machine, or you have some problem related to your local area network, you may have quality of service issues. So I was just trying to understand why the existing networks cannot be used for WebRTC, because I believe that WebRTC should be a function that is different from anything that's dependent on turn or stun for that matter.
Yeah.
And
so I think there's a couple pieces of that, the question. First is, why do we need to do this in the first place, right? And maybe the other question is, I mean, VoIP is not a new thing. WebRTC is not the first voice over IP service. So what do people do before? So on the first part, actually voice over IP has always had this problem, right? Originally, the original way to solve this, before these ICE mechanisms came into play, there wasn't a great way to do it. So companies, and one of the ones I worked at, put together a product known as the session border controller, right? And use a mechanism known as latching or hosted relay, right? Or essentially, it acts a lot, acted like a lot like a turn server. Those devices required a lot of intelligence, did a lot of things, and they're kind of expensive. So what, in developing WebRTC and the standards, and in VoIP in general, the movement's been to get away from being so dependent on anchoring media in the network all the time to moving to more of a peer-to-peer mechanism, right? And that's exactly what this ICE, mechanism does. So
how is this different from the VPN solutions we have, such as DMVPN or the easy VPN solutions that we have? How is this different from that?
Well, I think one, this is much more sensitive to real-time communication. So if you go back to all the different options that I had, like the turn TLS, that's probably the most similar to a typical VPN scenario. Okay. But you also have the worst, that's also the worst quality, right? Okay. So in general, you want lower latency, and VPNs add a lot of latency.
I mean, we are just speaking about RTP traffic that's flowing from peer to peer. And voice quality is anything that has a loss of more than 1% in terms of packet loss or latency. That particular call or that particular RTP stream generally has a quality of service issue. So I would believe that the VPN solutions that we have, or the solutions that we currently have, already have the mechanism to support this. Because if not, you would always run into a quality of service issue wherein any packet loss or any latency on the RTP traffic would cause a quality of service issue. So that's what I believe, because according to the quality of service definition, anything that any call or any RTP stream that has a loss of more than 1% is a quality of service issue.
Yeah. Well, we probably should take this during the break. It is a little more complex than that. Just bear in mind that with any voice over IP service, you're actually not getting all the packets through. And if we're talking and that packet comes through a second too late, it doesn't matter. It might as well not have been sent at all, right? So it's a very complex process to deal with all this. I can say for certainty, because this is not a new problem, this has been worked on for a long time, this ICE mechanism is the lightest weight and best way to do this. So I think
yep, we need to move.
Yeah.
We're out of time.